So I have prepared a short example here to illustrate that. So let's assume we have a market portfolio of these two securities here. There are only two securities in the world. I call them stock A and B, and A has 150 stocks outstanding and B has 100 stocks. Right, so that's our market portfolio, that's the supply, and we keep that fixed. Right, so that's what's available theoretically to buy. Suppose we observe a set of prices and we do our optimization for the tangency portfolio. And our outcome is going to be that we want to have two stocks of A and one stock of B, sort of relative to each other. Think of this as portfolio weights and not as absolute amounts. It's probably easier. So this will be a W of A of basically 2/3, and the portfolio weight of the second will be 1/3. Right? So that's kind of the relation that we kind of want to have. It's more about the relative amounts of the stocks. It's not about the how many exactly you want to have. Okay, so the question is this an equilibrium, yes or no? Right. So think about two cases. Suppose the investors, that's the first bullet here, have 150 stocks of A, right? They bought 150 stocks, so they bought all of A. Now, given their optimization, how many stocks B do they want to have? Well, they want to have 2/3 of A. That means they only want to have 1/3 of B. So they only want to have 75 stocks B, given that their optimization is correct. Right? So can that be an equilibrium? Unfortunately, no, because there are 100 stocks B outstanding. So what happens with the remaining 25? Right? So again, supply needs to be equal to demand. So we need to find someone to buy the remaining 25 stocks. So that doesn't work. Now let's assume the opposite case. Suppose they bought all the 100 stocks B, so that problem is solved. Now how many stocks A do they want to have? Again, the ratio should be 1/3, 2/3. So now they want to have 200 stocks of A. Can that be an equilibrium? Again, no, right? Because there are only 150 stocks of A out there, so where do we get the other 50 from that investors want to have? So that's not going to work either. Right. So the conclusion is the prices of A and B can't be correct. So what we see is that people want to have more of stock A as there is available. So basically A is too cheap. Right? So what can we do to fix this? We increase the price of A, then redo the optimization until finally the optimization reveals the same ratio of stocks like in the market portfolio. Right? And the ratio at the end should be 3 stocks A per 2 stocks B. Right? So the optimal ratio here will be kind of 3/5 for A, and WB will be 2/5. Again, assuming that supply is constant in the short run, you could also say that company A can maybe just issue more shares, right? That could solve the problem. But given that's the only way how you can fix this problem, then the prices should adjust in a way that your tendency portfolio has the following optimal weights. Right? So here, the first thing that we would try is increase the price of A or lower the price of B, which one it doesn't really matter. And we redo the optimization, and hopefully we get closer to this kind of optimal allocation. All right? So now we assume that everything kind of happens at the same time. Right? But remember that every time you change the prices, the optimization from the last chapter should change, right? Because the dots are now at different spots in the graph. Right? So if you change the return of the price and then the return of something, you get a new picture and you have to redo your optimization. Right? So you might have already seen that the first page that I was looking at here. This one here has the portfolio theory on the left here. That's now already representing the equilibrium outcome. Right? So the prices here have adjusted such that supply is equal to demand. So technically speaking, it's not really the same plot as before, because before we could draw it for any prices, and here it's a very special set of prices and returns that's behind it. Everyone fine with this equilibrium assumption? So then let's move on to what this kind of technically means. And now would be the time to go back to our previous chapter. So if we look at this point here, there's one thing that I have not explained to you yet is how to get the tangency portfolio kind of mathematically, right? I mean, we can draw it very nicely because we just have to figure out the tangent, right? So if you have a ruler and the pen, that's very easy to graphically do. The problem is, how do you do that mathematically, or if you have kind of many different assets, like how can you kind of easily figure this out? And there is a simple, well, it probably doesn't look simple at first glance, but it's a straightforward result that holds for any tangency portfolio. And it's important that it does not require equilibrium to hold. Right? And this is the formulas that I skip here. So if you have a tangency portfolio, then the following relationship holds for every asset in the economy. So let's see what we have here. In the numerator, we have the excess return of a certain asset K, right? So just pick one of my stocks, and this is my excess return of that stock. And that, so that's my level of my return. So it looks a little bit like a Sharpe ratio, but it isn't quite the same. So I have my excess return here in the numerator. And here I have my covariance between the stock that I'm looking at and the tangency portfolio. And the claim is that for every stock that you have, this ratio is constant if the covariance here is correct, is computed with respect to the correct tangency portfolio. Right. So this holds for any stock that the ratio of kind of excess return to covariance with respect to the tangency portfolio is constant. And why is there a covariance? Maybe to give you an intuition, let's look quickly back to one of the formulas that we had previously. So this was our portfolio volatility, right? So that could be the tangency portfolio's volatility, right? And how do we get this? Well, it's the sum over portfolio weights multiplied with the covariance. Right? So what is the covariance? The covariance is the contribution to a portfolio variance of a single asset. So that's why the covariance appears here, right? So if you split up the variance of a portfolio to how much of that variance comes from a single asset, that is exactly the covariance, right? If it is a well-diversified portfolio, to be fair, but the tangency portfolio is diversified, so we can use that. So let's annotate this here. It's an important finding. So this is the covariance of stock or asset K with the tangency portfolio. It is equal to contribution of shorten this a little bit. It's the contribution to portfolio variance. So you can basically test whether you found a tangency portfolio by picking just basically any kind of assets and computing this ratio, and it will be the same for everyone. Then you found your tangency portfolio. So maybe let's do a simple example with two stocks. So let's have two stocks A and B, the ones that we had before, right? So the picture looks something like this. How do I figure out where my tangency portfolio is? So how do I determine the T here? Well, you would set up a condition now. You would use this formula because the ratio has to be the same for every stock. So let's write this just down for two stocks. So the return of the first stock, A, minus the risk-free rate, has to be divided by the covariance of RA with the tangency portfolio, has has to be the same as the ratio for the second stock. So mu B minus Rf divided by covariance of Rb and Rt. Now, how is this helpful to determine? Let's quickly zoom out. Not quite sure. You want to rather zoom in or zoom out?
That was okay.
Okay. I think I can make it a little bit larger. The screen is a little bit small sometimes, just to see the picture. So, for the tangency portfolio, you need to know the portfolio weights. So how do you get from that? Get that from here? Well, you need to kind of plug in an equation for the tangency portfolio here. So the return of the tangency portfolio is your portfolio weight of A times the return of A plus 1 minus the portfolio weight of A, that's the weight of B basically, times the return of B.